Okay, everyone, let's start today with a little bit of review that's going to help us as we go forward in our new material. So I'd love for you to take out a piece of paper. These would be our SMART problems if we were in class. And I'm asking you to factor the two quadratic trinomials in 1 and 2. And then 3, 4, and 5 are asking you to solve. This is just a two-step equation, two-step equation. This one's actually just a one-step equation. So can you pause the video, factor the first two, and solve the next three? And we'll come back in a second and check how you did. Okay, factoring. This is one of the easy ones where the a is 1. So two linear binomial. Notice we've got a 30 out here. I mean, you got 1 and 30, 2 and 15, 5 and 6. Ring a bell right there, right? So did you get x plus 6 and x plus 5? And again, remember the order doesn't matter how you write these two binomials. Oh, the next one's tough. The 6 has got choices out front. It could be the 1 and the 6 or the 2 and the 3. The good news is back here we only have the 1 and 3 combination because 3 is prime. Did you get it? It is the 3 and the 2 combination. So if you look and we look at the OI, if we look at the outer, this is going to give us a positive 9x, and the inner is going to be a negative 2x, and 9x plus a negative 2x will give us that positive 7x. So there is the factoring that we did in the first half of Unit 8. Simple two-step equation here. You're going to subtract 3 and divide by 2. Answer is x equals negative 3 over 2. And, you know, it is okay to do the negative 1.5 because we're going to be talking about positioning on the graph. Here you would add 1 and divide by 3. We're talking about 1/3. Yes, it is about 0.3. It's 0.3 repeating. And here we're just going to divide by 87, and it's funny how a lot of people get confused by that, but 0 divided by 87 is just 0. So just some practice on factoring and some solving simple equations. Let's take it up a notch. So here again, I have 2 asking you to solve things that we've just talked about recently. So I'm going to ask you to pause and see if you can solve that quadratic equation. Number 6, and then I want you to look at 7, and obviously we got a star in the words problem here. Just kind of figure out why, what's going on. So pause, and we'll be right back. Okay, to solve this equation, we're going to add 7 to both sides and get x squared equals 36. Since it's a quadratic, to undo the squaring, we're going to take the square root of both sides, and the square root of 36 is going to give us a plus or minus 6. And you might remember in our last lesson we talked about that not only is the vertex a special spot in that parabola or a special point, so are the 2 points where that parabola crosses the x-axis. And here we can see that for this one it would be at a plus or minus 6. So, you know, what's the problem down here? You know, why can't we solve this one? And the problem is, as I alluded to at the end of our last video, none of the ones that we did in our last section had a bx term. And this one has a bx term. You know, how do you solve that? If you add the 7x, you've got an x squared over here and an x over there. And, you know, we don't know how to solve that way. So today we're going to learn a new method. So today we're going to solve quadratic equations by factoring. Finally, people, we're going to figure out why the heck do we have to do all that factoring, right? So today we're going to use factoring to solve a quadratic equation to find those 2 roots, the 2 points on the x-axis where the parabola intersects the x-axis. So let's take a look. And we're going to start right off the bat with something called the zero product rule. So let's just go up here. You can only use square root of both sides to solve an equation where x squared equals c. There is no bx term. If you have a bx term, square roots do not work. So for some equations, and notice the word some, you can use what's called the zero product rule. So before we go any further, I want you to imagine that I'm holding 2 numbers in my hands, one in my left hand and one in my right hand. You don't know what the 2 numbers are. And the only thing I tell you that if I take those two numbers and multiply them, the answer, the product, would be 0. And I ask you, what do you know? Well, if I have two numbers and they multiply to equal 0, so A and B would be the numbers that you don't know what they are because they're in my hands. And if I multiply them and get 0, then either A or B, one of them has to be 0. It could be 0 times 8. It could be 100 times 0. But you have to have one of those two factors be 0, either A or B. That's going to be the whole foundation for what we're doing today. So I just want you to look right down here, and you might recognize on the left, man, this looks like the answer to a factoring problem, doesn't it? But anyway, don't worry about that yet. Notice that I've got something in green and something in purple. Green times purple equals 0. That means that either the green has to be 0 or the purple has to be 0, because I have two things multiplying to 0. One of them has to be 0. Hey, this is a silly one-step equation. Just add 9 to both sides, x equals 9. This is a silly one-step equation. Subtract 2 and I get x equals -2. Now watch what happens if we substitute back in x equals 9 into both spots. 9 minus 9 would be 0. 9 plus 2 would be 11. 0 times 11 would be 0. Now what if we did it with the x equals -2? -2 minus 9 would give me -11. -2 plus 2 is 0. And -11 times 0 is 0. So these two numbers are the only two numbers that would work to give me an answer of 0. That's called the zero product rule, and we're going to use that to solve our quadratic equations today that have a bx term. So right up here, here is an equation that's got that bx term. Now, the first thing we're going to do today is to make sure that all the terms are on one side. Remember, we need it equaling 0 because that equaling 0 represents the x-axis, the y equals 0, which is the x-axis. So the first thing we're going to do is we're going to subtract 18. And does everybody see that equation? So subtract 18 from both sides, and this is what the equation would look like. The next thing we're going to do is, because we have that bx, we're not going to talk about square roots. Instead, we're going to ask, can we factor this quadratic trinomial into two linear binomials, or, is there a GCF? So the first thing, is there a GCF? There's no greatest common factor. Next thing, can I factor this quadratic trinomial? And I want you to pause the video right now and see if you can figure out what the factorization would be of this quadratic trinomial, and then come back. Okay, did you get it? X minus 9 and x plus 2. So again, remember that you can FOIL your factorization to see if it's right. So if we take the first, x times x would give us x squared. Outer would give us a positive 2x. Inner would give us a negative 9x. Positive 2, negative 9 would combine to give us the negative 7x. And then our last would be negative 9 times positive 2. A negative times a positive would give us a negative 18. And this is a good factorization. Now, if you take a look at this, it might look familiar. See it right here? So, I didn't give you this. We had to factor to get to there. But once we factor to get to there, we're going to use our zero product rule. So either the x minus 9 has to equal 0 or the x plus 2 has to equal 0. And we solve those two equations and get the 9 and the negative 2. And I already talked to you about checking. But here, we're going to check back in this original. So we're going to take the 9 and square it. Minus 7 times 9 and make sure it equals 18. And we're going to do the negative 2 squared. Don't forget to catch it in the gloves, in the parentheses. Minus 7 times negative 2, does that equal 18? And here is the math. And you would see that 81 minus the 63 minus the 18 will give you the 0, and the same thing over here. Okay, so as we start this, let me start gently. We're not going to have to factor on 1, 2, and 3. We just have to figure out what the roots are, what their solutions. These are already factored for you. So it's kind of scaffolded. So right now, what values of x would make this true? What values of x would make this true? And then down here, when you get to number 4, now you have to do the factorization into the two linear binomials and then solve it. Why don't you pause the video and try to do that yourself? Okay, let's see how you did. So either the x minus 3 has to equal 0 or the x minus 7, because when you have two things that multiply to 0, one or the other has to equal 0. Easy one-step equation, this is a 3. Easy one-step equation, that's a 7. And there are my answers. To number 2, I'll tell you, this is where people make mistakes, because they'll just go in here and say, oh, it's -2 and -4. No, no, no. This is going to be a 2-step equation this time. This was only a 1-step. So either the 7x plus 2 has to equal 0, or the 5x plus 4 has to equal 0. You're going to subtract 2 and divide by 7. You're going to subtract 4 and divide by 5, and there would be your 2 answers. Same thing down below. Either the 2x plus 3 equals 0 or the 3x minus 1. You're going to subtract 3 and divide by 2. You're going to add 1 and divide by 3. And there are your 2 answers. And what these 2 values are is where a parabola hits the x-axis. Okay, so now this one, we got to do all the work. So first of all, we need to look for a greatest common factor, which was the one thing, to be honest, in the last test and the factoring quiz where people were missing. You've always got to look for the GCF first to have it completely factored, and it's really going to be important in some of the problems we're doing today. There is no GCF here, and now I'm looking for the factorization, and did you get those two? Notice that there's the x squared. We have a minus 5x and a positive 12x, which would combine to a positive 7x. And 12 times -5 is -60, so this is the factorization. This is an easy zero product because we know that has to be -12 and it has to be a 5 because it's just simple one-step equations. So that's what we're doing today, and we're finally seeing where we're using our factoring. Okay, so how about if you take a look at this one now? The first thing I want you to do is to look and check for a GCF, and if there isn't one, you're now going to write your factoring equaling 0. Make sure you write that next step with your factorization equaling 0. Don't leave off the equal 0 part when you factor it, because that's the preciseness of the math that allows you to do the next step. Pause the video and see if you can factor this one, and then solve it. So you factor it first, and then solve it using the zero product rule next. Okay, did you get the factorization? We got to get multiplied to that 55. It is a 5 and 11, but they both have to be negative, because a negative times a negative will give you the positive. But notice the b is negative, so they both have to be negative. So we're going to get x minus 11 equaling 0 and x minus 5 equaling 0. Did you get 11 and 5? Now to check that, you need the 11 to go back in the original and the 5 to go back in the original. Check the math and make sure it works. Pick up my calculator, square the 11, minus 16 times 11, add 55. You will see 0. And if you do it with the 5, you will also see 0. So this parabola, if we were to graph it, is going to open up because the a is positive. And since it hits the x-axis in 2 spots, its vertex must be below the x-axis, and it's going to hit at positive 5 and 11. So it's kind of shifted over to the right. Okay, so this one's a little bit different. I do see a bx term, but there's kind of the c missing here. So before we go any further, I want to remind you that you always look for a GCF. Do you see it? There is a t in both of these. What happens if we factor that t out in front? We would have t out in front times t minus 5. We still can do our zero product rule because we have two things multiplying to 0. T is 0 or t minus 5 is 0. So here are our two statements. This one takes absolutely no thought. This one we just have to add 5. and the parabola will hit at 0 and 5. It is going to open up, and it is vertex below the x-axis, and it's hitting at these two places. If we put 0 back in the original and the 5 back in the original, you will see that they both check out just fine. Okay, let's go on and try another example. So immediately, what you should be saying, and again, this was something for some of you that was missed on the factoring quiz and test, something's wrong. We have a cubic here. This is not a quadratic. So if we are going to be able to do any kind of factoring, this has got to be a squared. There has to be a GCF. And if you notice, the GCF is x. There is no number. So I'm going to pull the x out in front. And when I do, I leave this quadratic trinomial. And now I'm going to look at him. Can I go a step further? And can I factor this? Pause the video and see if you can figure out the factoring for the x squared plus 4x minus 32. Write the two binomials, and this x will be out in front coming for the ride. Okay, did you get it? Did you get the x plus 8 and the x minus 4? Do you see 3 things multiplying to give you 0? You still have to have one of them equaling 0 in order for this product, this multiplication, to be 0. So either the x is going to equal 0, or the x plus 8 is going to equal 0, or the x minus 4 is going to equal 0. 0, negative 8, positive 4. 3 places that this cubic is going to hit the graph. Now, unfortunately, not being in class, it's really hard to try to draw this with the mouse. So I just went out just to show you what an example of a cubic would be. It's not the right numbers. It's not the 0, negative 8, and 4, but at least shows you. Remember that a cubic is that hurricane symbol. And if you notice, see 1, 2, 3 roots. So when you get these 3 answers, this is kind of what the picture looks like, and it's hitting in 3 places. Like I said, sorry about the numbers being kind of off on the graph paper. Okay, I'm going to check, put the 0 back in the original. It works. I'm going to put the negative 8 back into the original to make sure it works. Do my negative 8 to the third is negative 512. 4 times this is, remember to catch that negative 8 in the gloves to make sure you realize this should be positive. And a negative times a negative. And sure enough, it works. And then I can put the 4 in. Cool thing is you can put your answers back in the original and you can check them. So you know if you've done it correctly. So a cubic will have usually 3 roots. Okay, so now this one is just looking a bit like a train wreck, a bit of a mess, but we've got like terms all over the place. So the first thing we need to do is we need to have a 0 in order to solve a quadratic. So we need this 3y squared to move to the other side and this negative 3y. So we're going to do algebra first by subtracting the 3y squared from both sides. Need this still to come over and join his like term. So we're going to add 3y to both sides. And when we do that, we finally have a nice cleaned up quadratic equation that we can solve. I would like you to pause the video right now. You're going to look for a GCF. If there is one, you're going to pull it out. And then you're going to factor what's remaining or factor this if there's not a GCF. Please pause and come back once you have it. Okay, this time, we've got a number other than 1 in front. The good news is the A's prime and the C's prime, so that made it a little bit easier. Did you get this, these 2 linear binomials? This one's obvious right now. He's going to be a 3 in order to make him 0, right? This is the one you have to be careful on. A lot of people will do this in their head wrong. You're going to let 2y plus 1 equal 0. You are going to subtract 1 and then divide by 2, and you should be getting a negative 1/2, negative 0.5, and again, this one was sort of the easy one. The negative 1/2 has to go back, or again, we're going to put it back into that original, and notice I'm using 0.5, and I check it in the calculator, and it works with a 2.25 on both sides. I put the 3 in, and I get an 18 on both sides. So these two answers check. So that's a nice thing about solving equations, whether they're quadratic or linear. You can do a check. It's just with a quadratic, you could have two answers. Usually you do. With a cubic, you usually have three. We are going to see a couple exceptions in a moment. Okay, so we started doing vertical motion back a couple of sections ago when we were graphing with the BX, and I told you down the road you'd be expected to write these. So we're kind of taking it one step further. Again, we're throwing a tennis ball directly up. We're starting that velocity with 46 feet per second. That's the force I'm putting behind it. And we're going to start at a height of 6 feet. So as I'm releasing the ball, it's 6 feet above the ground. And we want to know, when will the ball hit the ground? So I just want you to see that this is your general form for vertical motion. The T represents the time, and in this case in seconds. The V is going to represent the initial velocity in feet per second. The S out here, which is our C, when we do our standard form of a quadratic, that is your initial height. Where does the ball start? And the H is the height above the ground at that given time. So if you throw a tennis ball up directly with a starting velocity of 46 feet per second, ask yourself, where does the 46 go? Does it go in for the H, the T, the V, the S? Where does it go? Did you say the V? It's the initial velocity. So we're going to replace that V with the 46. So what is this 6 feet? We already have the V. Is that the S, the H, the T? What is that? It is a height, so it has to be S or H. And the question is it the start height, or is it the height at a given time other than the start height? And you'll see that it's starting velocity. We start at 6 feet, so this 6 is going to be the S. And then we want to know, when will the ball hit the ground? What is a height of the ground? It is 0. We want to know when the H is 0. When did it land on the ground? So these are sort of the values that we're going to put in for our variables. H, the sort of the end height or the height at a given time, in this case will be the ground, is 0. The time is the question. When? So that's the unknown. It's going to stay a T. The V, we already talked about being a 46, and the S, the start height, is a 6. And we substitute those values in, and now we're going to use our new understanding to solve this quadratic. And when we solve it, the T will tell us, when did the ball hit the ground? So here is our quadratic. The first thing you're going to do is look for your BFF, and finally, do you see? There is a GCF. All of these guys are even. So if we pull out, and notice I pulled out the -2, because what that does is makes this positive, and this makes it easier to factor. So a -2 times 8 is a -16. A -2 times -23t will give us the 46t, and a -2 times a -3 will be a +6. Now, can I factor this further? The prime C is helping me out here, but out front, is it 1 and 8, or is it 2 and 4? Can you pause the video, please, and factor? And when you factor, there will be a -2 out in front of your two binomials. Okay, which combo was it? Did you get the t minus 3 and the 8t plus 1? So now we have three things and asking if they equal 0. Well, first of all, -2 can never equal 0, so forget about him. What is the t going to be here? Do you see that it will be 3 seconds? And this one, I'm going to subtract 1 and divide by 8. And do you see -1/8 seconds? So what is my answer? Well, the time of -1/8 doesn't make any sense, but the time of 3 seconds. So it will take 3 seconds. The ball will go up. It will come back down. It will hit the ground at 3 seconds. So that's my final answer. I just want to mention what this means. Do you remember that the ball started 6 feet off the ground? So in order to have the full parabola, if we went, quote, back in time, -1/8 seconds, that would put it sort of at the ground when we started if it wasn't 6 feet off. But doesn't make any sense. We want to know after we throw it, when will it land? And it will be 3 seconds. So that's sort of the start of our factoring. We're going to spend a couple days on this practicing, but please understand that this is the only video. Come back and watch it if you need to. And of course, there will be a filled in notes page as well. So finally, we answer the question, why do we factor? And the answer is, for some quadratic equations, we can use factoring to find the roots, the solutions. Where does the parabola hit the x-axis? So there it is, guys. Reason for factoring. I hope you all have a great day.